we're going to do section 3.3. This is on page 112, and it's called Measures of Relative Standing. Okay, so one of the things we're going to be doing in this section is we're going to be comparing data. So data, when you do comparisons of data, they're not always the same. So for example, if you compare heights, if we were to collect the data of all the heights of the students in our classroom, and we measure who was the tallest and who was the shortest, and then we do the same thing with the Spurs. Let's say that we record the highest and tallest person in the Spurs organization. Of course, their tallest person is not going to be the same as ours, and their shortest person is not going to be the same as ours. So we need to be able to compare data and then standardize it in a way so that we can see who is relatively tall or who's relatively short within their group. So that's what this section is talking about. So we first talk about the standardizing part of it is called the z-score. Okay, so what is a z-score? So let's look at the definition. And the z-score is right here. A z-score is found by converting value to a standardized scale. Okay. So the scale looks like the number line. So if we draw a number line, at the number line, of course, in the center of the number line, you have 0. On the right, you have the positives. 1, 2, 3, 4, 5, and so on. And then you have your negatives. 1, 2, 3, 4, 5. Get your number line. And so the scale is cut off. Cut off at the -2 and at the +2. Okay. So when you compute the z-score formula, I'm going to show you in a minute, you're going to get this number. So that number, that z-score number, if it falls within these two boundary values, this area here in the middle, we say that it is usual. If it goes beyond 2 or below -2, we consider those unusual. Unusual. Okay, so here's these formulas. There's two of them. You can use the same. Either one is the same, but you have two formulas. So here's the sample one. The sample one goes z equals parentheses x minus x bar over s. Okay. So if you remember, what is x bar? X bar is the sample mean. The s is the sample standard deviation. Okay, when you plug them in, this x is going to be the value that you're going to measure. You want to see whether or not it falls in this scale. Where does it fall? So you use that measurement. Let's say that I want to record your height. I want to see whether or not your height is usual or unusual. Well, you would put in your recording value, and then you subtract whatever the mean sample is, and then subtract it, and then divide by the sample standard deviation. You get that number, and then you plot it. Okay, that's for the sample one. If you're dealing with population, here's the formula. X minus mu over curly O sigma. So you remember what mu was. Mu is the population mean, and the O is the population standard deviation. Okay, so you can either use this formula or you can use this one. It doesn't matter. You should get the same result. Okay, so let's try an example. Okay, so let's say that okay, so let me get some data. Okay, let's say that we're gonna measure your height. Okay, and I'm gonna look it up here. For the population, we're gonna find the mean standard deviation for both males and females in the United States. So let's see, mean and standard deviation. Okay, there it is. So in the United States, in the US, it says that the mean height for women, we'll do the women. Okay, the mean is hold on, is 163.83 centimeters, and the standard deviation is 6.35 centimeters. I'm getting that from Google. Google's telling me that. Okay, now let's say that that's given. All right, and let's say woman, I ask a woman, what is your height? Right, and they say, well, we'll just call her Jane Doe. Jane Doe, her height is, let's say 5 feet 4 inches. Okay, and I want to know what her z-score value is, and then I want to plot it on my scale, right? Because this is my z-score scale. Okay, so notice that if you guys are going to be going into the medical field, you're going to need to know how to convert everything to centimeters, because all the heights are measured in centimeters, and then kilograms is the weight. So you got to know how to convert. So let's look at Jane Doe's, and let's convert her height into centimeters. So how do I do it? Well, first of all, I have to convert feet into inches. So I have to multiply by 12. So that gives me 60 inches, right? And then I tack on that extra 4 inches. So she is 64 inches, right? But I need it in centimeters. So I have to convert, we need to convert centimeters, sorry, inches to centimeters, right? So you remember how to do that, how to convert inches to centimeters? There's a conversion. It's 1 inch equals 2.54 centimeters. So you have to write it as a ratio. That is a fraction, right? So either you write it as 1 inch over 2.54 centimeters, or you write 2.54 centimeters over 1 inch. Well, you write it in a way so that the inches are diagonal, so you can cancel them. So you had to put 2.54 here, centimeters, and you put the 1 inch. So that way, inches cancel, and then you just multiply 64 times 2.54, which gives us Jane Doe's height in centimeters. So 64 times 2.54, she is 162.56 centimeters. That is what Jane Doe's height is. So now let's find her z-score. Okay, so I'm going to use the formula z equals x minus x bar over s, or you can use the other one, don't matter. So there's my x. My x is this Jane Doe's number, 162.56 centimeters. And then we're going to subtract the mean. What was our mean? It was 163.83. And then I'm going to divide it by 6.35. And then I punch it in my calculator with the parentheses, of course. 162.56 minus 163.83 divided by 6.35. She has a z-score value of negative 0.2. So on the scale, where does she fall? Where does Jane Doe fall on the scale? Let's take a look. Where does it fall? So 0. Negative, so it should be about right there. That's where she is at. So she is considered usual. So it is usual for her height to be that usual, because among all females, that's pretty much almost a usual weight among women is 5'4". Now, of course, when you're dealing with heights, right, you could have extreme issues, right? So you remember a basketball player by the name of Shaquille O'Neal? Well, Shaquille O'Neal is pretty tall. Where would he be at? Would he be over here? Or would he be over here? Yeah, he would probably be way over here. I bet he went off the scale because his height is really unusually high. Right. What about Danny DeVito? You know who Danny DeVito is? Danny DeVito's a little short guy. He's coming out on M&M commercials, the little short one. He is probably over here, small. He is small. He's considered unusually small, so he would be on the left scale. You guys probably have an aunt that's small or tall, whatever, but they're unusual. Yeah. All right. So let's look at an example. The one in the book has an example of extreme tallness and extreme shortness. So if we go to our exercises and we'll do number 13 in your Libro, see if I can find the page. I believe it's on page 125. Number 13, number 125, on page 125. Hold on. Book. It is number 13. Right? So, tallest living man at this time, at this time when the book was written, I think it was 2005. So it's been a while back. But at that time, 2005, the tallest living man at that time was a guy named by the name of Sultan Kosen. He had a height of 251 centimeters. The shortest living man at that time was Chandra Bahadur Dangi, who had a height of 54.6 centimeters. Okay, so let's record. So they're gonna give you two things. So they're gonna give you both the mean and standard deviation, right? So let's look at the mean and standard deviation. So what's given? So we know that the mean for men was 174.12 centimeters, right? And the standard deviation was 7.10 centimeters. And the question is, which of those two men has the height that is more extreme? Okay, so let's start with Mr. Kosen. Okay, so Mr. Kosen, we're gonna find his z-score. So I'm gonna do z equals, we'll use the other formula, x minus mu over sigma, and then we'll compute his, let's see, what was Mr. Kosen's height? Mr. Kosen's height was 251 centimeters. Whoa, it's a little tall. And then we'll do Dangy's. Dangy's height was, what was his height? 54.6 centimeters. And we'll use that, we'll do that formula also for his height. So x minus mu over sigma. Okay. Switch. Here we go. Okay, and we plug it in. So Mr. Kosen's height was 251 centimeters minus 174.12, and then we'll divide by 7.10. We're going to calculate it. And that gives us, let's see, use parentheses. 10.83. Okay, 10.83. That's Kosen, Mr. Kosen's z-score height. Okay. Now let's do Mr. Dangy's. I'm going to plug it in. His was 54.6, and then we subtract the mean, 174.12 divided by 710, 7.10, that's 710, but 7.10, and let's compute it. 174.12 divided by 7.10. Negative 16.83. That is Mr. Dangy's, and that is Mr. Kosen. So it looks like, boy, it looks like Mr. Dangy's height was much further than Mr. Kosen. So let's look where, so Kosen's 10. This is 10, so I have to extend it 8, 9, 6, 7. I went over, but I mean, you can tell this is much further away from 0 than 10 is, right? So he is much further. He is the most extreme. And if you Google both of those gentlemen, they have a picture of both of them standing side by side. And interesting enough, they're both married. Can you believe that? They're both married. More extreme. Okay, so that's how that works. Okay, now let's look at number 9 because I know you're gonna ask me, sir, how do you do number 9? Okay, so let me show you how to do number 9. So number 9 requires some algebra. Okay, it's gonna require some algebra that you're gonna have to do. But the thing is, when you do this algebra, you need to know how to set it up first, right? So recall, let's see, you guys recall taking the ACT? The ACT test is used to assess readiness for college. In a recent year, the mean ACT score was 21.1 and standard deviation was 5.1. Right, so they're giving you, right? They're giving you the mean, which is, what was the mean? 21.1. They gave you the standard deviation of 5.1. Okay. Now they want to know, identify the ACT scores that are significantly low or significantly high. All right. So what does that mean? So they want to know, what are the cutoff values on the Z-score? Remember we had -2 and 2? Those are your cutoffs. They want to know, what are the most extreme high and what's the extreme low on an ACT test that you can achieve. Okay. So here's what you do. So you're gonna write down the Z formula twice. So we're gonna do the low end. We're gonna do x minus mu. Yeah, we'll do mu over sigma because I think they're doing all of ACT scores. And then we're gonna do the high, same formula. Z equals x minus mu over sigma. And we are going to substitute the, remember, what were the extreme numbers? It was -2 and +2. So that's where those numbers are going to come in. So this is the low end, and the +2 is the high end, right? And then we substitute. Well, I don't know what x is. That's what we're trying to find, but I do know what my mean is. It's 21.1, and I know my standard deviation is 5.1. Same thing over here. X minus 21.1 divided by 5.1. Okay, and then this is where you guys are going to use algebra. Okay, so let's see if you guys recall, how do I solve this for x? Well, I got to get rid of that 5.1. So whatever you do, it's an equation, solving an equation. So what we do is we multiply both sides by 5.1. Doing that cancels this with this, right? And so I calculate what is 5.1 times -2. 5.1 times -2 is -10.2. Okay, so that cancels, so I'm left with x minus 21.1. Over here, you're going to do the same thing. You multiply both sides by 5.1. Cancel, cancel. This one, you end up with a positive 10.2 equals x minus 21.1. Do you remember how to solve for x? We solve for x in an equation. Whatever you do to one side, you got to do the other, right? So I'm going to add 21.1 to both sides because that's what algebra tells me to do. And I find out that if I do -10.2 plus 21.1, I get 10.9 for that one. And then for this one, I'm going to add 21.1. What's up? I got the cancel X. I'm going to add 10.2 plus 21.1, 31.3. So if you want to be in the usual end, you need to score on your SAT between 31.3 and a 10.9. Woo, that's a high score. I don't think I ever got that high. I didn't do well on the English part, but the math, oh, I did great on that. Yeah. But the English, I could never do the vocabulary. Not for me, people, not for me. Okay, so that's how you do number 9. Number 11 is going to work the same way. You're going to set it up the same way with the 2, the negative 2. You're going to just replace the 21.1 and the 5.1 with the new figures that they have for the mean and standard deviation. Same thing. Same thing. So that's how you do z-scores. Now, since we got z-scores and we talked about ACT exams, right? There's another test that you may have taken. How many of y'all have ever taken the SAT test? I think most of y'all have taken the SAT test. Of course, these tests, the ACT, SAT, those are all standardized tests. So you take the test, and then that wasn't the difficult part. The difficult part was being able to figure out what the paperwork that they brought back to you. What did those results tell you when you took the test? Right? You're like, well, what does that tell me? Well, what those tests do is they compare your score with all the kids that took the test like you. And they rank y'all, and then they place you where you stand in relation to what the other students did on their test. And they position you, they put you in groups. Oh, you were in the top group, you did well, or you were in the middle group or in the bottom group. So they place you in groups. And then they rank you, and then they place you in groups, and they tell you whether you did well or not. And it's just a comparison. That's all that they're doing. They're just comparing you with all the other students that took it. So it's kind of like GPA. When you're in high school, you had a GPA and you had a rank, right? In high school, you had ranks. So how did that work? High school ranks. I didn't turn on the light. Hello. Right. So high school ranks. So you had they base it off of your GPA, which is totally different nowadays. Not the same when I was in school. When I was in school, it was just whatever grade you got, that was it. But they didn't have like categories like you had AP classes, honor classes, dual credit. Excuse me. Those actually change the ranks. And so, yeah, apparently there's 2 ranks. You have the high school rank and you have the college rank. So it's all programmed differently per district. Anyways, so in ranks you had the geek, of course, rank number 1. That would not be me. And these were all geeks here, right? So you had the top, maybe you had the top 5%, top 10%, whatever. They grouped them. They put them in groups. And you know who I'm talking about, right? The people, the top people that had high ranks are up there, and they had them top 10% or whatever, right? So they put them in groups, and they categorize them by percentage. Those percentages are called percentiles. Okay? Percentiles. All right, so let me show you what the definition of a percentile is, and then I'll show you how that works. You're going to go to page you're going to go to page 115. Okay, and there's the yellow definition. I'm going to write it down. What is a percentile? Percentiles are measures of location, and they denoted by, they put a P and then they put a subscript, like a number below it. P1, P subscript 2, P subscript 3, blah, 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 all the way to P subscript 99. That's how you write a percentile. What do these do? They divide a set of data. I'm not going to put 100. They group them. They put the set of data into groups with about 1% of the data of the values in each group. So it's important to put the data in order. You must order the data from smallest to largest. Very important that you put them from largest to smallest. Okay. Let me share my screen. I'm going to tell you what I wrote. Just the smallest to largest. Smallest to largest. Smallest to largest. Smallest to largest. Okay. Very important. Very important. I'm going to put a star there. Gotta do that. Okay, so there's going to be two ways of doing it. Okay, you're going to go one way, and then we're going to go reverse. Right. So we're going to show you first how do you finding the percentile of a data value. Okay. And there's a formula for it. Okay, so this is an important formula. So here it is. The formula is percentile of value x is equal to, they should have put it in parentheses. So I'm gonna put a big parenthesis. I'm gonna have a numerator and the denominator. The numerator is a number of values less than x. Oh, I'm not gonna have space. Oh yeah, well, over total number of values, close it, and then multiply by 100. Number of values less than x. Zoom it up. So the number of values less than x. It's bothering me, I'm sorry. Less than x. Less than x. Divided by the total number of values times 100. And it says, very important, it says round to the nearest whole number. Okay. So let me show you how it works. Okay. I'm going to give you a data set, and we're going to use the one on page 115. Okay, we're going to go to page 115, and I'm going to ask you to put the number from the table. So here's how it works. The top, okay, the top. It's kind of like, you ever play board games like Monopoly, Sorry, or you roll the dice, and then when you roll the dice, you have to move your piece. You get your piece, and you have to count spaces. Okay, well that's the process of how this is gonna work. You pretend you're gonna roll a pair of dice, and whatever the number is, you're gonna count spaces. Count spaces. Okay, that's the trick. That's the top part. You're gonna be counting spaces. Okay, so here we go. Let's pick a. Let's go to the table. 115. Oh, it is 115. All right, there it is. Okay, y'all see the table? We're going to use table 3, 4. All right, so the table is already in order. Notice it goes from smallest, it goes row by row. There's the first row, second row, third row, fourth row. They're in order. They're all in order from smallest all the way down to the highest. Okay, so they're in order. So let's pick a number, any number in the table, any number. Right? So let's pick, I don't know, 14.2. We'll choose 14.2. I want to find the percentile where 14.2 lies in. Okay, so there's my first example. I want to find the percentile of value 14.2. Okay, so we'll go to 14.2, right? The numerator, this top number, the numerator, this number of values less than x, right? This one. Okay, this part right there. Here's 14.2. I want to count how many numbers are before or smaller than 14.2. So I have to count them. I have to count all the numbers that are smaller than 14.2. So it's going to be that one, 1, 2, 3, 4, 5, 6. And I think these are all tens. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so that's 20. 1, 22, 23, 24, 25, 26. There are 26 numbers before 14.2. So I'm going to put 26 on the top because there's 26 numbers. And then on the bottom, where it says total number of values, I'm going to count the entire number of numbers in this yellow box. What is the total number of numbers in this box? They go in, there's 10 per row, so that's 10, there's 5 rows, so that's 50. 50. Okay, so that's where we got the 50. Okay, so 26. 26 is the number of numbers before 14.2 divided by the total 50. Now I'm going to punch it in my calculator. 26 over 50 times 100. This is how I entered it in my calculator. 26 over 50 times 100. I get 52. So you're going to write your answer as P under subscript 52, or you guys can write it as 52nd percentile. Either or is good. I would prefer that one. That one is much cleaner, I guess. Okay. That's how it works. Okay, let's pick another number on the table. Let's do, I don't know, 7.9. 7.9. Let's find the percentile of value 7.9. Okay, now how many numbers are before or smaller than 7.9? Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 12. There's 12 numbers. There are 12 numbers before or smaller than 7.9, right? 12 numbers. So I'm going to put 12 over 50 because that was the total number of numbers in my data set, the whole entire box. 12 over 50 times 100. Over 50 times 100. 24. So my answer is P24 or the 24th percentile. Either one is. Okay. Let's do an interesting one. Let's choose a number where they duplicate. There's a repeat of a value. What do? If they repeat. All right, let's take a look at one. Is there one that repeats? Which one repeats? 11.1 repeats. So let's find the percentile of 11.1. Okay, so if I do formula, the number of numbers before 11.1. So the way it works is you locate the very first time 11.1 appears. See how there's two of them? There's one, there's two, all right? So you're gonna use that one as a base, right? As its base, and you're gonna count how many numbers are before the very first time 11.1 appears. So we're gonna count from here on down. So that is, how many is that? 1, 2, 3, 4, 5, 6, 7, and then there's 10 up there, so that's 17. So there's a total of 17 numbers, right? 17 numbers, did I count it right? 17 numbers? 17 numbers before the first 11.9, 11.1. I'm going to divide that by 50 and then multiply by 100. So 17 over 50. Oops. 17 over 50. 50. 100. 34. So my answer is P34 or 34th percentile. Right. Anyways, percentile. Percentile. Okay. All right. So all good. Excellent. Okay. So you guys can now do the homework on page 125. So the ones on page 125, show you. 125 is the next page. All right, 126. There you go. So 126. Problems 17 through 20 are exactly like the ones that we just did. Okay, so they're giving you the entire list. I believe there are 50 numbers and they're in order. You have to find the percentiles for each of those four. Is it even working? No. How that is not working. But yeah, these 17 through 20 are like the ones that we just did. So see if you guys can do those, and you should be good if you know how to do them. Okay, if not, you can ask me questions next time we meet. Okay? All right, so now we're going to do it the other way. What happens if I am given a, we're going backwards. If I'm given a percentile, how do I go back and find the score of where it came from? Okay, so we're going to go backwards. So to go backwards, this is what it's called. It's on page, what is it? It is on page 116. There it is, 116 right here. We're going backwards. We're going to be converting a percentile to a data value. I'm going to show you all how to convert backwards. Converting a percentile to a data value. Page 116. All right, so they gave you a flow chart. Look at this flow chart. You got to follow that flow chart to a T. Right, so we're going to follow it. We're going to follow that flow chart. And so I'm going to go over it with you all. Okay. Okay. Let's look at the flow chart. Okay. So in order to do the converting a percentile to a data value, this is going to be, it looks challenging, but it's not. You just have to follow the steps, and you got to know the notation, right? So let's go through the notation first. So the notation, what do they have? It says they denote the lowercase n to represent the total number of values in the data set. Okay. They use K, lowercase k, that represents the percentile being used. Percentile being used. So, like for example, you have the 25th percentile. K is 25. Okay, and then L is going to represent the locator. It is the locator value that gives the position of a value, the L. And then if you put PK, remember the subscript? PK, that is the kth percentile. So you have to have, you need to know these notations. Okay, very important. I know those. You don't have to memorize them. You just have to know them. Okay. All right. So here's what you do. You start by arranging the order from smallest to largest. If they are not in order, you have to put them from smallest to largest. And then you go in and you compute the formula. So here's the main formula. Okay. So the main formula is L. So you're going to put L equals K over 100 times N. Okay. N represents a number of values. K is the percentile in question. So, for example, let me show you. Let me show you an example. So it'll say find the indicated percentile. Find the indicated percentile of P62. Okay, so we'll give you a data set, right? And then what you're gonna do is this is your K number. That's the K. That number is gonna go right there. So you would do L equals, you put your 62, you put it over 100, and then you multiply by N. N is going to represent the total number of data. Okay, well, we'll see. We'll figure that out in a little bit. Okay, that's how it goes. So they're going to give you, remember, like our answers, I told you to write it as P and then the number on the bottom. That number on the subscript is the K. Okay, that's the K. So you plug them in. That's this part here, and then you're gonna compute it. So then whatever our N is, you're gonna multiply that N, and you're gonna fill this out, and you're gonna get a number. Okay. Now, L is either gonna end up being a whole number, or it's gonna be a decimal. Okay. So let me go over those two steps. Right. This is very important. Okay. So I'm gonna write down the steps. So these are the steps. Put step one. Put data in order from smallest to largest. Okay. Step two. Find L, which is K over 100 times N. Compute. Right, you're going to plug it in and then compute it. Then step four, you're going to have there's two options. So we'll put A. If L is a decimal value. Okay, if it's a decimal value, you're going to round up. Round up. Okay, even if it's 2.71, this is going to end up being 3. Or if it's 2.41, you're still going to bump it up to 3. Even if it's 2.01, you're still going to round it to 3. You bump it up. You got to round it up. Regardless, if whatever decimal is behind it, the only time you don't round it if it's just plain straight 2, then you don't round it. You just bump. You're just going to leave it as 2. Right? So regardless, if there's any decimals behind it, you got to bump it up, round the number up. Then start at the first smallest value on the list. Count L value spaces. Where you land, that is your answer. So you're going to start at the first smallest value on the list. And you're going to count L value spaces. And then where you land, that is your answer. So let's do one. I can show you how it works. Okay, so I'm gonna put B. I need to put a B. So can you guys leave space for B? We're gonna put B here in a minute. Okay. All right. So let me show you. So let's do one. Let's do the one in your book. We're gonna do the one on page, I think it's 115, where the table with the Verizon numbers were at. Let me see. No. Yeah. Page 115. So let's go to page 115 and we'll do one. Okay. That was previous page. Cool. So let's say I want to continue. I want to find find the percentile for P62. Okay, P62. And I want to use this data here. Okay, so first of all, I gotta count how many numbers are they in all here? There are 50. Is that correct? There should be 50 numbers. Okay, so there's 50. All right, so cool. Let's go back. Share it. Okay. I want to find P62, right? So I'm going to do, and they're in order, so I don't have to do the ordering part. So I'm going to do L equals K over 100 times N. So my K is 62 divided by 100 times 50. I had 50 data on that yellow box. Is that correct? I had 50 of them. So I'm going to compute it. Put it in my handy dandy. You can use parentheses. You don't have to use parentheses. It don't matter. It should work either way. Let's do it. 62 over 100 times 50. I get, oh, it came out to a whole number. That's not what I wanted. I wanted a decimal. All right, hold on. Let's do come on, marker work. Let's do 67. Sorry, let's do 67. Yeah, I wanted to come out to a decimal. Right, so 67. Let's change that 62 to a 67. Let's see what comes out. I want it to be a decimal. This thing doesn't want to work. I think I broke it. It don't matter. 67. Okay, so here we go. Let's try it again. 67 over 50. No. 67 over 100. 33.5. Bam! All right, there it is. So it ended up being 33.5. So I have to bump it up, which ends up being 34. Right? So you're going to count 34 spaces. Okay, so remember I told you about the when you roll your die when you're playing a game. Right? You're playing a game like Monopoly, whatever, what have you, right? And then you roll your dice. Okay, so I'm gonna count 41 spaces. Golly, I don't know how to spell. Sorry. Okay, so you're gonna go back to your data set and go to this table and count 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. Bam! Right there. That is value 34. So my answer is value 17.5. Bam. So there's my answer. It is 17.5. You have to count. Starting at the beginning, you count spaces. You got to count 34 spaces from that first number on the list. You count that number. And that's how you get your. That makes sense? Can we do another one? Let's pick another one. Let's do P. Let's do P. Let's do P. Let's do P. I don't know. What do we do? P 50 something? P 58. Or no, we're gonna do an odd. Let's do P 50 something. No, I'll fix it. We'll do P. Let's find the percentile of value 50, P59. All right, P59. Okay, so here we go. We're going to use the same data set. We're going to do L equals K over 100 times 10. Here's my K. It's 59. Times, and I believe there were 50 numbers on that Verizon thing. I'm going to compute it on my formula, my calculator, sorry. Plug it in. 50 over 100. Sorry, 59. $29.5. Right. So what do we do when the answer for my L comes out to be a decimal? I have to bump it up, which is 30. So you're going to count 30 spaces from the beginning. Right. So let's go back. Go back to my and count 30. I think they go in tens. That's why does it want to click now? There you go. 1, that's 10, 20, 30, I believe 30, that's 30. There it is. Value 15.1. It falls right on it. So it's value 15.1. Right, so you have to count spaces. That number, that L value is spaces you have to count, not an actual number, but it's the number of spaces you have to count from the very beginning. You have to count spaces. So that's how it works. If your L ends up being a decimal, these are decimals. Decimal. Oh, marker smells good. Ooh. Okay. Right, that's what happens when it comes out to decimal. So now what happens, like I did before, you know how it came out to 62, it came out to a whole number. Well, that's a whole different story. Okay, so let me show you what happens if L ends up being a whole number. Okay, so here it is. So if L is a whole number, whole value, I'm going to count L spaces and then get that value and take the average of that number and the one right after it. Right, so you're gonna take the average. You're gonna get the L plus the one after it, L plus after, and then divided by 2. L plus after divided by 2. That's how it's gonna work. So I'll show you how it works. Okay, so now we can do the P. We can do the P. We can do the P62. P62. Here's my pen. All right. Okay, so let's do the P62 just to show you. P62. So let's see how it works. We'll do a couple of examples you can see here. Let's find the percentile for P62. Okay, so they're in order. I'm going to do L equals 62 over 100 times 50, right? Because that was the number of data in our thing. I'm gonna type it into my calculator. You can see it, 62. Darker, hello. There you go. 62 over 100 times 50. Notice I get 31. See how 31 is a whole number? Okay, so you're gonna count. You're gonna go to the 31st value on the list. You're gonna count. You're gonna count 31 spaces. All right. And remember, you're gonna take the average. You're gonna take the average of that number. Right? Count 31 spaces. All right, let's go. Let's count 31 spaces in our list. Here we go. Here we go. Count 31. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going left to right. 11, 12, 13, 14, 15, 16, 20. Come on. 20, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Right there. That's the 31st value. So it's 15.5. I'm going to put it in, was that blue? Ah, what did I do with my blue pen? I had a nice blue pen. Anyways, I'll have to use purple. So 15.5. There it is. Right? And then the one after it. This one. So I'm going to get my 15.5 and my 15.8. And I got to take the average of those two numbers. That's the 31st, and you want to go to the one after it, 32nd. Right? Oh, why did I do that for? I'm going to add them and divide by 2. That's what this 15.5 is. That's the 31st space. So I'm going to add 15.5 plus 15.8 divided by 2. My answer is 15.65. And you leave the answer like that. There it is. See, what's happening is, you guys remember when we found the median for a data set that was even, you're going to have two middle numbers. That's what's happening when the percentile ends up being an even number. You end up with like a median. You're going to have two middle numbers. That's what happens. All right, let's do another one. Let's do, I don't know. What do you want to do? We're going to do P. We're going to find, give me a percentile that's even. Percentile and even number. Okay, someone said 34. All right, let's do P34. Okay, so again, we're going to do L equals 34. Over 100 times 50. Put in our calculator. Times 17. We get 17. 17 is a whole number, right? So I'm going to count 17 spaces, and I got to find the average. What is the 17th value on the list? 17th space. Let's see, what's the 17th value on the list? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There is a 17th value. It's 10.9. So 10.9 is my 17th value on the list. And then I got to go to the one after it. So I got to take the average of these two numbers, 10.9 and 11.1. Find the average. There you go. 10.9 plus 11.1 plus 2, 11. Interesting. It comes out to be 11 right on the dot. Value 11. Okay. So see, these are ended up being whole numbers. Whole value. Whole. Use my highlighter. Whole value. You got to do that. You got to count that many number of spaces, and then take the average of that number, the one right after it. That's how you do the converting a percentile into a data value. So there's that's the fourth, and that's the second rule. Doing that. Let me see. Let me put my. Okay, so let's go over it again. Decimal. What do? You bump it up, count that number, and then you bump it up. Then you count that many number of spaces, and where you land, that's your answer. If L is a whole number, you gotta count L spaces, then get that value and take the number, and then take that number and the one after it, and then take the average. Take the average. L plus after divided by 2. And don't round it. Just leave it like that. So those are the two ways. So when you do the exercises in the book, those are going to be on page 26, I think. Yeah, those are like columns 21 through 28. Right? And you're going to be using this data right here. There's 50 of them. So that's what you're going to use to find those columns from 20. For some reason it won't let me highlight it. (21 to 20). Okay, now you're probably wondering, well, what is this Q thing, sir? You didn't show us how to do Q. Okay, let me show you how to do the Q's. There's not really much for Q's, but those are called quartiles. Okay, quartiles. What are quartiles? Quartiles separate the data into 4 groups. Q1, Q2, and Q3. 4 groups. All right, okay, so you're saying, wait a minute, sir, I only see 3 numbers, Q1, Q2, Q3. Shouldn't there be a Q4? No. There's no Q4. These values split it up into 4 groups. You have a group before Q1, you have a group in between Q1 and Q2, you have a group between Q2, Q3, and then you have a group after Q3. There's 1, 2, 3, 4. These are separated. They split it up equally into 4 groups. So they're divided into 4 groups. So that means that they're grouped in quarters. There are quarters. So there isn't really much of any steps. All you can do is we can split this up and rewrite this in terms of percentiles. So remember, they're quarters. You're splitting them into quarters. So basically, Q1 is really P25. Q2 is really P50. Q3 is really P75. So if you guys see these Qs, Q1 is really P25. All you have to do is convert it, Qs to a percentile. Q1 is P25. Q2 is really P50. Q3 is really P75. So let's do one. Let's do the one in the book. Let's do number 23. I think 23 is in your homework, right? So let's find Q3. All right, so this is page 126, number 23. It says find Q3. All right, what is the conversion from Q to P for Q3? Q3 was what? What was Q3? Q3 is, let's look. Q3 is P75. So we're gonna do the percentile. Right? So how do I do percentile? Remember? All right, so I'm gonna do L equals 75 over 100. And I believe there were 50 data on that set. So I'm going to calculate that. Right, let's count just to make sure. I want to make sure. There should be 50. I think there's 10 per row. 10, 20, 30, 40, 50. There's 50. Yeah, there's 50. So let's compute it. 75 over 100 times 50. 37.5. Ooh, 37. Uh-oh. What do we do if we get a decimal? Do you remember? You remember? What do we do if you get a decimal? This is a decimal. What do you do if this ends up being a decimal? What do? Do we count 37 spaces and then we the one after it and take the average? Or do I just bump it up and then count? Yes, that is correct. I gotta bump it up. That becomes 38. So I'm gonna count 38 spaces and see where it lands on the data. So let's count 38 spaces. That's 10, 20, this is 30, this is 40, but I need 38. 40, 40, 39, 38. Bam, 3.8. Value 3.8. 1 to 10, 20, 30, 31, 32, 33, 34, 35, 36, 37, 38. It won't let me click. Anyways, value 3.8. Piece of cake. So anytime you see Q's, anytime you see a Q value, you convert it into a percentile and then follow our steps. You can memorize this if you want, but I don't think you need to remember. There it is. Okay, so there's our Q's. And now the last thing I'm going to show you, and that is creating a box plot. See that? Box plot. So a box plot see if we can find box plot. Box plot. Somewhere over here. Box plot. Close. Next page. Previous. 119, I believe. Nope. Next one. There it is. Box plot. it's a page 119. Box plot is, they also call it box and whisker. Kind of like a cat. You know how a cat has whiskers? I wonder what happens if you cut the whiskers off a cat. Ah, you don't want to know. We don't want to know. That's right. It is a graph of a data set that consists of a line extending from the minimum value to the maximum value, and a box with lines drawn at Q1, the median, which is really Q2, and Q3. So what do we need? We need four things. We need the minimum value. We need Q1. We need Q2. We need Q3. And we need the max value. It's a 5-number summary. That's what they call it. 5-number summary. And as you recall, you remember what Q1 was? What was Q1? Q1 was really what? P25. Q2 was P50. And Q3 is P75. So you need to find those 5 things. And then you draw a box plot. So let me show you guys what the box plot looks like. I'm going to show you what a bell-shaped one looks like. So this is what a bell shape. This is a good way to graph data to see if it's skewed or bell-shaped. So this is what it looks like if it's bell-shaped. Okay. So use your vivid imagination and tell me what this looks like. Huh? What does it look like? In Star Wars, right? The TIE fighter. It looks exactly like the TIE fighter. I was gonna put little lasers, but it's a TIE fighter. It looks exactly like a TIE fighter. It is a perfect box in the center, and it's centered right exactly in the middle. That's what a bell shape data would look like. If it's skewed, oh, you'll know it's skewed. Right? You'll have something like the rectangle, the square is no longer a square, it's more of a rectangle and it's off. That is skewed. So this line is the minimum. This is the max, this other line at the end. And then this is your Q1, this is your Q2, and this is your Q3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's 5 little lines. So you're going to draw these. Well, actually, you're not going to draw them. StatDisk is going to draw them for you. So we're going to use StatDisk. We use StatDisk to draw for us. Okay. So here's what you need to do. You're going to, here are the steps. You're going to enter the data as one column. I don't know how to spell column on stat disk. Okay. Then you go to data, I believe. Let's see. Let me see. I forgot. You're gonna put all your data. You're gonna put it all there. Type them in. It's gotta be a column. It's gotta be a column. You gotta type in all the data in one column. You don't have to put them in order. Just type them in one column. Then you go to data, and there should be a window called boxplot. Click on, select data, choose boxplot, right? Click on it, and you're going to type in column 1. You're going to choose 1, choose box 1. I guess you call it box 1, and then you click on boxplot. Actually, you know what? Never mind. There's another way. It's easier. It's much easier. I think you guys might like this one instead. All right. So scratch that. Scratch that. All right. So I'm gonna go back to the data. Okay. So you're gonna still type in the data on this column. Okay. Type it in that column. You see where it says data tools? You're gonna select data tools. Okay. You're gonna select data tools, and then you're gonna select explore data. Choose explore data. You choose explore data, and you're gonna select column. Choose column 1. Select 1. Okay. And then you're gonna click on evaluate. Evaluate. And it should come up. Okay, so let's try 1. Let me show you. Let me show you. Lettuce, tomato. Let's go back to page 126. Actually, 126. All right. And let's do number 29, speed dating. What the heck is speed dating? I have no idea what speed dating is. I'm just accustomed to farmers only. That's how we met. I'm kidding. That we didn't need right. All right. So we're going to type in all these numbers in. You got to type all these. Yeah, you guys are going to have to type all these. You cannot load, you cannot upload the data from the data sets. You're going to have to type them in. Sorry. We'll have to type it in. Right, so I'm going to type in all these numbers. You can't do it here. I can't do it here. I can't copy them. It won't let me do it. So I have to type them in. All right, so here I go. I'm going to type them in. I'm doing number 29. So let me, hold on. Before I do that, let me give you guys the rules so you guys can write it down. Hold on. Here you go. Here are the rules. So here are the steps on how to do it via StatDisk. And then we'll do number 29 on page 126. We'll do page 126, number 29. We're going to create a box file for number 29. All right, so copy that down. That's how you do it on StatDisk. Boxplot StatDisk. And then we'll do number 21. Here we go. So I'm going to type in the data. Let's see if I know how to type very well. 2.0. I don't think it's going to let me. Yeah, we'll do 3.0, 4.0, 5.0. How many 6.0s are there? Two 6.0s. Hold on. Jeez. Okay. Back on track, baby. 2.0, 3.0, 5.0, 6.0, 6.0. Okay, how many 7.0s are there? 1, 2, 3, 4, 6, 7.0s. Six. Yeah, I have 6. 1, 2, 3, 4, 5, 6. Yep, 6. Okay, 8.0s. Let's see how many 8.0s. 1, 2, 3, 4. 4 of them. Nine point oh. 9.5. And 2 10.0. Okay. Right. So I type them all in. I'm going to go to data tools. I'm going to click on explore data. I'm going to hit select column 1, evaluate. Presto, there it is. Bang. Oh wow, look at that. It gave you the minimum, the Q1, the median. Wow, they gave you everything. What the fuck? Look at that. And you can download. Look, I got it. And I can open up the Word document. And I think I can paste it. I can paste it. Let me see. Sure. Paste it. Oh no, I didn't do it. What? That's my Zoom. Hold on. Let me see. What did I do? Oh, I didn't download it. Hello, hello. Copy. Can I copy it? Oh, yeah, I can copy it. Copy and paste it in my Word. Bam! Oh, that's huge. Yeah. Okay, so it worked. Let me see. Let's zoom back out. Let's go back. Go back to my picture. All right. So here's what I did. I clicked on the camera. It's a download pod as PGN. I clicked on the camera, and then I once it downloads it on my computer, I'm gonna click on it. It's opening it. Right. I'm gonna right click on it, copy, open up Word. Paste. Oof. Ooh, there it is. Ooh, there it is. Ooh, it looks skewed to me. It's not directly in the center. It is a box. It's a perfect box, but it's skewed because it's this line is longer than this line, so it's skewed. Make sense? Okay. All right. Let me see. And the other ones are going to be similar. similar. Let me see. Go back to my. Where's my? So you do the same thing for 31 radiation beta 2. That sounds interesting. You do. Oh, this one you can do. Look, you can do pulse rates. You can do the pulse rates of. You can create a box plot with the data. Yeah, you can do. Yeah, these require you to download the data from your set disk, and you can create your box plot. But 31, you'll have to type them in. All right, cool. So that's how you do your box plots. Let me know if you have any issues with them, and we'll discuss it on probably Wednesday. If not, we will, or Thursday, or if not, next week. All right, take care.